Hi everyone, this is going to be a video walkthrough on question 4 on CS61B, Spring 2017, Midterm 1. Okay. It begins by asking us or telling us to consider the declarations below, and we know that the Falcon class extends the Bird class. Okay, so the first thing I want to do is figure out the static and dynamic types of the objects Bird and Falcon. Okay, so looking at this Bird object, what is its static type, what is its dynamic type? Let's first take a step back and remember what the static type is, what the dynamic type is, right? The static type, to put it simply, is the type of the object, okay? It's what appears to the left, right? That's what the static type is. When we think about the dynamic type, I like to think about it as what the object actually is. Looking over here, we can see that this bird object is of static type bird and dynamic type falcon, because the type of the object is bird, and it actually is an instance of the falcon class. Cool. So with that, what we can do is we could fill in these right here. Okay, so moving on to falcon. This one's a bit trickier. So the first thing that we can immediately conclude is that falcon is of static type falcon, right? Because of this line right here. The next one is a bit trickier, and we're trying to figure out what the dynamic type of falcon is. So falcon is equal to this bird object, right? The dynamic type of this bird object is a falcon, so the dynamic type of falcon is also falcon, okay? And I want to take a step back here and ask like what's really going on in this assignment, because we're playing with the casts. Casts sometimes make things confusing. Okay, so I'm going to argue right now. This is a little off the track of the question, but I think it's really important for understanding dynamic method selection. Is, do we need this cast here? Like, why is it even there? Like, what role does it serve? So think about that for a couple seconds. Okay. We actually do need this cast. The reason we need this cast is what we're trying to do is set an object of static type falcon equal to this bird object, right? If this cast were not there, we would try to set an object of static type falcon equal to an object of static type bird. That doesn't work because a bird isn't necessarily a falcon, right? That would throw a compilation error. To remedy that, what we're going to do is we're going to temporarily change the static type of the bird object to falcon. Okay. Now what's going to happen is that during compile time, it looks at the object over here, and it says this object has static type falcon because of the cast. Then during runtime, it says that falcon, right, this falcon object is going to be equal to bird, which is actually a falcon, right? Because it has dynamic type falcon. So with this cast, the code perfectly works. Cool, that was a good tangent. Hopefully you guys enjoyed that. Let's move on to the actual meat of this question. So it says, consider the following possible features for the bird and falcon classes. Assume that all methods are instance methods. And I kind of took F1, F2, F3, and F4, and I drew them to the side right here. Okay, so my shorthand is G is for Gulgate, B is for bird, and F is for falcon. Okay, so the question asks us, suppose we make a call to bird.gulgatebird. Okay, and it says which features are sufficient alone for this call to compile. For example, if feature F3 or feature F4 alone will allow this call to compile, fill in F3 and F4 boxes. So what we're trying to do is figure out which method, when included, causes this code to compile. Okay? So since we only care about compile time, that's a very clear indication that we care about the static type of bird. Right? Because during compilation, we care about the static type. During runtime, we care about the dynamic type. Okay? So looking at this method, what this really is asking us is there a, give me a sec, is there a Gulgate bird method in the bird class? Okay, that's what this question is really asking us. Okay, and that's what this method execution is really asking. So how did I jump to this conclusion? So bird is of static type bird. So when this method gets executed, or when this function call gets executed, what we do is we look in the bird class for a Gulgate method that takes in a bird, right? So all it's really asking is there a Gulgate bird method in the bird class, right? So if we include f1, right, which is a Gulgate bird method in the bird class, we see that this would allow the code to compile because we look in the bird class, we see a Gulgate bird method, and then this function call is satisfied, right? Okay, so the next part is actually a continuation of the previous question. Select a set of features such that this call executes the bird Gulgate bird method, right? And what we know is that this method is precisely the method we chose in the previous part that would get executed when this is called, right? So this second part isn't actually asking us anything new. All it's saying is that f1, if it exists, will get executed, right? Because we know that from the previous part, if f1 exists and nobody else exists, f1 will get run. So in the second part, what we can say is that in order to ensure f1 is getting run, we could just add it in there because we know that it will get run if it exists and nobody else exists, right? So the next question, or next part says, select a set of features such that this call executes the Falcon Gulgate bird method, okay? So here, this is very important, and this is a classic example of dynamic method selection, okay? In order for us to execute the Gulgate bird method of the Falcon class, the only way of choosing a method that's lower in this so-called inheritance tree is using dynamic method selection, okay? Because what we're going to do when we execute bird.gulgate_bird is we will always look in the bird class for a Gulgate method that takes in a bird during compile time. We do that every single time, right? In order for that to work during compile time, f1 must exist. Then during runtime, if we've locked in on this method, right, dynamic method selection works such that if there's an identical method in the Falcon class, right, in other words, a method of the same signature as the method we locked in on during compile time, we will choose this method. So if f1 and f3 both exist, right, we will choose f1 during compile time and then choose f3 during runtime, okay? And what's also important here is that, or what's not important necessarily, but like a cool observation you can make is that f2 and f4 will never really get called for this question because since we're executing Gulgate and bird is of static type bird, it can never execute f2 or f4. So even if f2 or f4 existed, we will still execute this method. So we could add in f2 and f4 here, right? In the same light, for the previous part, we could add in f2 and f4. Okay. So moving on to part B. Suppose we make a call to falcon.gulgate falcon. Okay. So let's recall that falcon is of static and dynamic type falcon. I realize my face might be covering that. Okay. So looking at falcon.gulgate falcon, we know that the static and dynamic types are both falcon. So which feature f1 through f4, if it existed, will allow this function call to compile, Okay? And the quick answer is that all of them work, but I'll quickly explain why this is the case. So suppose that only the Gulgate bird method of the bird class existed. What will happen during compile time is that we will first look in the Falcon class, right? Because Falcon is of static type Falcon. And then we ask ourselves, is there a Gulgate method? There isn't. So what we do using inheritance is we look in the bird class and we ask ourselves, is there a Gulgate method that takes in a Falcon? Right? And we see that no such method exists because right now we're considering the possibility only F1 exists. And then we realize that we can still execute this function call if we had a Gulgate bird method. The reason a Gulgate bird method, if existed, would allow the code to compile is because a falcon is a bird, right? So if F2 doesn't exist, no worries, F1 would suffice, right? So what will happen here is that we can see that F1, if it exists, it will get called, right? Or it will allow the code to compile. And we can kind of think about it as F1 is being the toughest to get selected. So we can kind of use the same logic to see that if F2 only existed, right? Like suppose F2 only existed, we would see that the code would compile because it would choose F2, right? If F3 only existed, code would compile. If F4 only existed, code would compile. Okay? And like the quick intuition there is that since the static type and dynamic type are Falcon, we have access to Gulgate methods of that take in Falcon and birds, and we have access to the bird classes methods through inheritance. Okay? And then using that logic, we know that if any one of F1 through F4 existed and nobody else existed, the code would compile and F of I would get called, right? I'll say that again in like maybe a bit simpler terms. Suppose that F2 existed, right? And only F2. We know that F2 will get called, right? Because during compile time, we choose F2. During runtime, we choose F2, right? So if F2 existed, right, we will choose F2. If F1 existed, we will choose F1. Okay, so what we can do is we can simply say that for each one of these options, we can just say, what if F3 existed? The code would compile, right? And my quick jump here stems from my conclusion in the previous part, which is that if F1 only existed, the code would work, we choose F1. If only F3 existed, code would work, we choose F3. Right? Because of that, I jumped to this conclusion for these following parts right here. Okay, that is all for this question. I hope you guys enjoyed this walkthrough, and I wish you guys a good rest of the day.